Good morning, everyone. Today is November 27th, and we are starting our Unit 5, Lesson 1 today. So this unit, we're going to be dealing with trig identities. So hopefully you remember from grade 11. There's some basic trig identities, such as like the Pythagorean identity, sine squared plus cos squared equals 1. We get tan is equal to sine over cos, and then cotangent is just the reciprocal of that. And then we have our reciprocal identities, cosecant, secant, and cotangent. We are going to be learning a lot more identities in grade 12 compared to grade 11. So these are some of the basic ones that you should have seen from last year as well. Where if you square a reciprocal identity, it's the same thing as 1 over sine squared for cosecant squared. Tan squared is sine squared over cos squared. And this is the Pythagorean identity where sine squared plus cos squared equals 1. If you just rearrange it and just move one of the terms over, and then you have one for cotangent and tangent. And yeah, let's start doing some proving. These are some rules, or not rules, but like tips, you can say, to help you prove identities. So usually you separate your equation into left-hand side and right-hand side. That's LS and RS, left side, right side. Terms may not cross between the sides, so you can't just go over the equal sign. Can't do that. You have to try to change everything in terms of sine and cos. Remember, these are guidelines, not necessarily for every single example, but good guidelines to have. If you have fractions being added or subtracted, find a common denominator and then combine the fractions usually. Use difference of squares when you can. If you have 1 minus sine squared, that's the same thing as 1 minus sine times 1 plus sine. And you can use power rule. So for example, if I have sine to the power of 6, that's the same thing as sine squared brackets to the power of 3. So just some guidelines and rules. So let's get started on our first example here, which is we are going to prove that tan squared x plus 1 is equal to secant squared x. So remember, the first thing that we're going to do is try to convert everything in terms of sine and cos. Sorry, before that, we're going to have our left-hand side and right-hand side. Usually you pick one side and work on one side. And if you get stuck, depending on your teacher, for me, I'll allow it where you can work on one side, get as far as you can. If you get stuck, then you can start working on the right-hand side and see if you can meet in the middle somewhere. And I'll show you what I mean about that in the examples to come. So first step, tan squared x plus 1. That is our starting point here. And we're going to rearrange this in terms of sine and cos. And here we're adding two terms. So we're going to have a common denominator. In this case, the denominator is cos squared x. So this is just going to be cos squared x over cos squared x, because that's what 1 is. It's just 1 over 1, and then you times both the top and bottom by the denominator. And now we can add and combine these fractions. So this is going to be sine squared x plus cos squared x all over cos squared x. And we know from our trig identities that sine squared x plus cos squared x is the same thing as 1 over cos squared x. And at this point, if you want to, we can write our right-hand side as secant squared x, which is the same thing as 1 over cos squared x. And at this point, the left-hand side and right-hand side are exactly the same. So you end it off by writing this, and there you have it. So that is how you prove an identity using, the previous identities that were shown to you. All right, let's move on. Next example is going to be this one here. So cos squared x is equal to 1 minus sin x times 1 plus sin x. Let's see. Left-hand side, right-hand side. And you don't always have to work on the left-hand side. just so you are aware, you can start from the right hand side and simplify that side first. So in this case, you know, I'm going to multiply the bracket out. That's going to be 1. This is the same thing as a minus b times a plus b. So it's going to be a squared minus b squared. So here we have a, which is 1. 1 squared is 1. Minus sine squared x. And if you check our identities that were given, this is exactly equal to cos squared x. And now we can write left hand side is equal to right hand side. So here's an example in which I simplified on the right hand side first. Pretty straightforward, easy stuff. Now we're going to be learning about transformation identities. Oh wait, actually hold on, before we do that, did I do this? Oh no, sorry, there's one more example. Here we go, one more example here. So once again, left hand side, right hand side. And obviously left is sine squared x over 1 minus cos x. And this is just 1 plus cos x. I'm going to choose the left hand side to start with. And I know that sine squared x is the same thing as 1 minus cos squared x. The reason I do that is because I know that 1 minus cos squared x is the same thing as 1 plus cos x times 1 minus cos x all over 1 minus cos x. And since we have the exact same brackets, we can cancel out. Final answer is equal to 1 plus cos x. And that is exactly what our right hand side is. So at this point, we can write ls is equal to rs. Okay, that is the examples for the first part. Now we're going to do something a little bit more different. All right, transformation identities. Because of the periodic nature, there are many equivalent trigonometric expressions. Horizontal translations of pi over 2. And remember, pi over 2 is the same thing as 90 degrees, in case you're trying to make sense of that. That involve both a sine function and cosine function can be used to obtain two equivalent functions with the same graph. Translating the cosine function, pi over 2 to the right, f of x is equal to cos x minus pi over 2. Because remember, transformations left and right is your d value. And if you're transforming to the right, then your d value is positive pi over 2. So then when you're writing in the equation, it's x minus d, so it's going to be x minus pi over 2. So f of x is equal to cos x minus pi over 2. It results in the graph of the sine function. And hopefully you remember this. Okay. So when we translate the cosine function to the right by 90 degrees, we get the sine x function. And similarly, if we translate the sine function pi over 2 to the left, which would be f of x is equal to sine brackets x plus pi over 2, that would give us the cos x function. So that is called a transformation identity. And we can use this to help us. All right, so we have another type of identities, which are called kind of like even odd identities. So remember that cos x is an even function, and it reflects this graph across the y-axis, results in two equivalent functions with the same graph. So even, so y-axis, if I were to make this a mirror plane and reflect it, it would give me the exact same graph. So algebraically, what that looks like is y equals cos brackets negative theta is equal to y equals cos theta. Remember, you substitute a negative x value and you get the original function back. Sin x and tan x are both odd functions. They have rotational symmetry about the origin. So you have sin x in blue